Addition and subtraction of fractions, lines, and segments, problem set 1. What we're going to do is look at part 1, part 1A, pardon me, 1A. Um, so, common fraction rules. In order to add or subtract fractions, you must have a common denominator. So, this is true no matter how many fractions you have. As long as they all have common denominators, and these are all common, being 11, we keep the same denominator, and we just go ahead and add the numerator. 5 plus 2 is 7, plus 3 is 10, and then we would simplify if we can, and simplify in this case would mean to reduce to lowest terms. There are scenarios where obviously you do not have a common denominator, as in 1/3 plus 2/5. In this case, you have to rename your denominator. In order to do that, you find the least common multiple. You find the LCM, the least common multiple of the denominators, and you can do that by listing out the factors of the denominator, meaning that what are the numbers that multiplied or are divisible into this number. So 1 and 3. 5 are 1 and 5. Both of these are prime numbers, but we would talk about that later. And then we take each one of the factors, the most number of times it appears, and multiply them together to get the least common multiple. So 1 appears, 3 appears, and 5 appears. Each of those appear, of course, the most number of times 1 appears is once, because they both have that. So 1 times 3 times 5 is 15. So 15 is our least common multiple. So we rename the fractions with the denominator of 15. So now we need to find our new numerator. We simply find the relationship between 3 and 15. 3 times what is 15? Or 15 divided by 3 is what? The answer is 5. Of course, you know that. And we'll take that and we'll multiply it by our old numerator. And this will give us our new numerator. So 1 times 5 is 5. So we start again. 5 times what is 15? And of course, you know that it's 3. We'll take that 3 and we'll multiply it by our old numerator to get our new numerator. 2 times 3 is 6. Now we can add these fractions together, because in order to add or subtract fractions, you must have a common denominator. So our denominator stays the same. It is 15. And our numerator, 5 plus 6, is 11. Now we cannot reduce that fraction, so that is our lowest term that we can present that answer in. Okay, let me erase all this. All right. Now, let's look at this concept here. We're still in 1A, 1.A in your book. We have 13, pardon me, I have to unchoose my tool. We are looking at a mixed number. A mixed number is a whole number and a fraction, 13 and 3/5. This literally means 13 plus 3/5. And of course, we do not put the addition sign, but 13 and 3/5 is how we present this number here, called a mixed number. Okay. Now, what we want to make sure to understand is that in algebra, if I have b next to a whole number or a counting number or an integer, doesn't matter, 7b actually means 7 times b. But in this case, 13 and 3/5 does not mean, it does not mean 13 times 3/5. It does not mean that. No, no, no. Okay? So just understand that. So, looking at how we have to add or subtract mixed numbers, an example here is 13 and 3/5. 13 and 3/5 plus 2 and 1/8. 2 and 1/8. In this scenario, we have 13 plus 2, so that equals 15. We know that. However, we have our problem here again that we do not have a common denominator. So the LCM of 5 and 8 is 40. So 5 times what is 40? It's 8. We multiply that. 3 times 8 is 24. 8 times what is 40? It's 5. 1 times 5 is 5. So the fractional part of the answer is 29 over 40. So then we could just bring this up here. So it's 15 and 29 over 40. Okay? So this would be true whether we're adding or subtracting. We still have to have a common denominator, even in a mixed number. This is always true. All right, now let me go ahead and erase this board here. And let's look at this idea when we have to borrow. When we're subtracting and we have to borrow, right? So just quick concept review. If you have 100 minus 87, of course, 0 can't take this away, so we have to borrow. We make this 10, we make this 9, and this becomes 0, and of course, we're able to answer 13. Okay, so what happens when you're in a scenario with fractions and you have to borrow? Well, let's take a look. Here we have 13 and 3/5, 13 and 3/5 minus 2 and 7/8. And you can see this. This is at the bottom of page 1 in your book. Okay, this is the bottom problem on page 1 as an example. So 13 can take 2 away. We know that. But what we're going to do this time is we're going to keep all of these together as we rename our fractions. Okay, now I just quickly did that in my head. Remember, that's how many times does 5 go into 40? 8 times. We multiply the old numerator by that factor, and that's where we get 24 from. And then how many times does 8 go into 40? 5. So we multiply that. 7 times 5 is 35. And I'm going through this quickly because I'm assuming by the time you're in Algebra 1, you already know how to manipulate fractions. That's a prerequisite for coming into this class. Okay, so we have 13 and 24 over 40 minus 2 and 35 over 40. We have a problem here because 13 is bigger than 2. If I line this up vertically, it would look like this. And we could see 13 is bigger than 2, so we don't have to borrow. However, 24 is smaller than 35. So in this case, what do? We have to borrow. We have to borrow. So how do we borrow here? We're going to borrow from this whole number. We're going to take 1 from here. 13 minus 1 is 12. You already know that. And then we're going to move the one that we borrowed over here. Now, I'm assuming that you already know that when you are manipulating fractions, 1 is equal to any number over itself. 10 over 10. 1 is equal to 999 over 999. As long as the numerator and the denominator are the same, it will equal 1. So when I'm bringing 1 from the counting or whole number column to the fraction column, I'm bringing any particular fraction over that equals 1. Okay? Now, my denominator here is already 40. So what would be the intelligent thing to do to make our lives easy? As we're bringing 1 from the whole or counting number column to the fraction column, since the denominator is already 40, why don't we just make it, since 1 is equal to 40 over 40, 40 over 40, let's just put it over there as 40 over 40, since our denominator is already 40 over 40. So over here in this part, we have 24 over 40. And then when we borrowed the 1 to bring it over, we made it 40 over 40. When you add or subtract fractions, you have to have a common denominator. So our denominator is 40, so we go ahead and put it over here. And we can add 24 and 40, which equals 64. Now, since we borrowed from this column, brought 1 over, named it 40 over 40, we simply add it to the existing fraction. And now we rename that to 64 over 40. So let me rewrite all this down here without the arrows and such. We originally had 13 and 24 over 40 minus 2 and 35 over 40. We obviously can't subtract there because 24. So we cross this out. We make this 12. We cross this out and make it 64. Now we can subtract. 40 is our denominator. 64 minus 35 is 29. 12 minus 2 is 10. So 13 and 3/5 minus 2 and 7/8 is 10 and 29 over 40. 10 and 29 over 40. Now, quickly, did you see that we wound up with 64 over 40? Now, I want you to understand that we could have just done this. That is, I explained to you how and why you do this particular thing. But remember, we had 24 over 40, and we had this number 13. Okay? What we can do is just cross this out, make it 12, and add these two together. We get 64, because 40 plus 24 is 64. That's a shortcut. I only teach the shortcut after I teach you the reason why you do it. This is the why, and this is how it works. Okay? All right. That's the end of this part. Let me go ahead and erase all of this. Oh, got a little more over here. Okay. Next. 1.B. 1.B. We're talking about lines and segments here. Now, in the explanation of the book that you've already read, I'm sure, because you did your assignment, there's a statement. It is impossible, it's 1.B, page 2. It is on page 2. It is impossible to draw a mathematical line because a mathematical line is a straight line that has no width and no ends. Okay, so mathematically speaking, as soon as I draw this line, it has a width. Okay, this has a width. Now, let me show you. I could simply zoom in and make it bigger. All right. And you would be able to measure it with a ruler if I kept on zooming. A line in math, as well as what's called a graphed point along a line. We do this when we're learning to graph, but technically speaking, this point and this line in mathematics have no width. Now, you'll understand this later as you get higher in mathematics, but suffice it to say, it has no width and it doesn't really matter to you right now. This would matter to you later on if you were to study astronomy and physics, that because as soon as this has a width, it has mass because it's a thing, and therefore it would change the equations that you're working, etc. So let's not even worry about that right now. But that's what this sentence means. Okay? Now, let's go ahead and look at this example. Here we have a line. We know it's a line in math because of these two arrows on the ends. Because a definition of a line in mathematics is that it has no ends and no width. So that's what the arrow represents. It goes on to infinity. And the way you write infinity is this sideways 8. Okay. All right. Now, you have simply these points here graphed here in our example on page 2. Point A, point X, point C. Now, you can name any portion of this line that passes through any of these points. And you would name it like this. Okay, this is line AX. Now you see that little arrow, pardon me, the tiny little line with the two arrows on the end? That's what we call a line. Okay? You can do that for XC. You can do that for AC. Right? You can do it for CA if you want to name it, going from right to left, etc. And there are other examples in the book. Each one of these would determine, obviously, line A to X is from here to here, line X to C is from here to here, line A to C is from here to here, and line C to A is from there to there, right? So this is how you would describe a line in mathematics. Okay? You describe it with the graphed points, and you describe it with the line above it with the arrows on the end. Okay, now, next we have something called a line segment. A line segment. Okay, and a line segment, unlike a line, has a beginning and ending. In the text, you have it labeled as line segment MC. So the way you would say this, okay, those are your options there. Now, similarly, you would name the graphed points M and C, and you would just put a straight line with no arrows. You do not have to put graphed points on the end. They're done like this. Now, this is not in the book, but I will go ahead and put this on here. Of course, there is a point in here with an arrow on the end. This is called a ray. I believe this gets introduced later on in this book or in the next. It's a geometrical concept where you're going to go ahead and measure angles and such. But let's say you had 2 points along a ray named D and F. You could call this ray DF by having this with one side of an arrow, or FD. That one side has an arrow, unlike a line. Line XC has 2 arrows, representing that they both go in each direction infinitely. This represents that it goes in one direction infinitely. As you see here, it starts here. It has a beginning, but it has no end. Here you have both a beginning and an end. This should all be familiar language to you at this point. And that concludes the introduction of problem set 1.